Today we will discuss about the proportionality theorem, okay? So it is very easy to prove, okay? So you just need to remember the only 2 points, okay? If you remember the 2 points, you'll prove in the exam directly, okay? You need not to prepare anything, okay? So I'll try to explain you very clearly what are the 2 points you need to remember, okay, to prove this concept, okay? So what this theorem says, right? Okay, if you draw a parallel line to the any of the one side in a triangle, okay, that line intersects the 2 other sides, okay? That 2 sides will divide into the same ratios, okay? So by drawing a triangle, I will explain you more, okay? First you understand, right, about the theorem, okay, what it says. Then it is easy to prove, okay? And if you draw a diagram, the 80% of the problem is solved, okay? I will draw now I will draw a triangle. So let's take any triangle. So let's take any triangle. Just I'm marking the points similar to the book, same points, okay? Not having any confusion for you, okay? Not for me, for you at least, okay? So, okay, this triangle is ABC, okay? So now I'm drawing to the one parallel line to the any of this side, okay? Now let's draw a parallel line to the BC, okay? So I'm just drawing parallel line to the BC, okay? So this can be placed anywhere, okay? So this line can be placed anywhere, okay? But it should be parallel to the BC, okay? So I'm just placing here, okay? Parallel to the BC one line, okay? Let's mark these 2 points as D and E, okay? Let's mark these 2 points D and this is E, okay? So what theorem says, right? If you draw a parallel to the any of this side, okay? So I'm just drawn here for parallel to the BC here, okay? This is the D line is the parallel to the BC line. What this theorem says, right? If you draw a parallel line to the any of this side, that cuts the 2 other sides. So 2 other sides are this AB and AC, right? So it's cutting the other 2 sides at D point and E point, right? So if it cut, right, so then what it says, right? So it divides this AB line and AC line into the same ratios, okay? Same ratio means, see, so AD by BB is equal to AE by AC, same, okay? That means whatever the ratio it divides, okay? This line also will be divided into the same ratio, okay? This is the theorem, okay? Proving this, right, we just take the 2 things, okay? You need to know the triangle area formula, okay? So again, I'm just re-explaining the triangle area for a minute, okay, to understand better, okay? That is very much important to prove this theorem, okay? So for example, I have taken a triangle here, that's triangle ABC, okay? So let's draw a parallel line to the BC, okay, from the point A, okay? So let's take this the parallel line to the BC at the point, okay? Again, I'm extending this BC at some more distance. Now we have drawn a parallel line to the BC and from the point A. So the line is parallel to the BC, okay? So these 2 lines are the parallel, okay? I just extended the parallel line to here, okay? So let's take distance between these 2 lines is the H, okay? That we are referring is the height, okay? So how do you find the triangle area? It is half into base into height, right? Okay, so half, okay, what is the base here? BC is the base here, okay? What is the height here? H is the height, right? Now, let's draw any triangles, okay, between these 2 parallel lines by just making the BC as the fixed base, okay? For example, I'm drawing another triangle. I'm taking another point on the same parallel line, A dash, okay? I'm just drawing another triangle, okay? At the bottom. So if you take another triangle, A dash BC, okay? So it is also having the same base, right? So what will become the area of into same base BC? What is the height? The distance between the parallel lines will be the same, okay, everywhere, okay? Because these 2 are parallel lines going in parallel. For example, railway tracks, right? So both are in parallel always. So the distance between the 2 parallel lines will be fixed, okay? So that's we are calling the height of the triangle, right? So if you take the A dash here, this is calling the height of the triangle. If you take this triangle, okay, that is also same as the height of the triangle, okay? So it is same h, okay? So what are the triangles you created between these two parallel lines by making the same base? All are having the same area. Okay. So you remember this concept. Okay. This is a key thing to prove this theorem. Okay. As per the theorem, what do we need to prove? Okay, we need to prove AD by DB must be equal to AE by AC. Okay. When you draw a parallel line to the BC, that cuts the other two sides at a D and E. Okay. So then the two sides divide into the same ratios. That means AD by DB equal to AE by EC. Okay. This is what we need to prove. Okay. Now I will draw few lines. Okay. By joining just B and E. Okay. And D and C. And another thing, I just draw one perpendicular line from the B to AB. Okay. So there it makes a perpendicular. Okay. Similarly, I draw another from D to. Okay. Now, so this mark this point as M, this point as N. Okay. So here we have the perpendicular and here we have the okay. So if you draw this diagram, I think this most of I think your problems are solved to prove this one. Okay. Triangle DEB area. Okay. Triangle DEB area. Okay. So area in the triangle will be denoted with AR. Okay. AR DEB is written means DEB. So to take the triangle area DEB. Okay. That is equal to triangle area DEC. Okay. Why? Why it's equal? Just now we discussed it, right? So it has the same base. Both triangles have this triangle and this triangle has the same base. Okay. So same base it has and it has the same height. So distance between the two parallel lines is the same. Okay. So whatever the point it moves, for example, if you are fixing this base, D base you are fixing and B point you are moving. Okay. And it makes the different triangles, right? By changing from B to C, right? All the triangles having the same area. Okay. Since it's just the area of this triangle is just base into height, right? So we know this. Okay, let's take this the equation number 1. What is this equation? So the area of these two triangles are same. Okay, I will find the area of this triangle. Okay, divided by I will put the area of this triangle. Okay, so that why we are doing this, right? I just cover this sides, right? AD and DB it covers. Okay. To prove that we have in that sides, right? That's why we are taking, okay, what we do, right? We just will divide the area of this triangle divided by area of this triangle, okay? So what I'm trying to divide? Area of, what is the first triangle? ADE, right? So it is ADE divided by area of DBE, DEB, right? Okay. D and B. Okay. So what is the area of the ADE? Okay. So when taking this AD area, I'll take the base into height, right? I'm taking the base as the AD. Off into base as AD. What is the height? Height is perpendicular distance to the other point, right? So I just mark the perpendicular distance, right? That's the EN. Okay. Divided by, what is the area of this, right? Area of this. So, off into, what is the base? Base is BD here. What is the height? If we take this triangle, okay, what is the height? So, this is the height of height, okay? That's called EN, okay? It's clear, right? It's just base is this. And if you keep moving this point anywhere, okay? Between this, if you draw a parallel line here, so height of the triangle here is EN. Okay. So this is the one. So similarly, what I do, right? I do other side. Okay, other side triangle. ADE by BEC, okay. So I'm using this triangle now, okay, for the ratios. So AR divided by ADE divided by area of BEC equal to, first this area, right, same off into, now let me take this base, right? You can take, all are same, okay, base into height only put. Any side base you can take, any height you can take. While doing this side, I'll take this height, so that the base will become the AE, okay. So here the base will become the AE and height will become the DM, right? So DM divided by, so this area if I want to find, I am finding off into, I'm taking this as the base, EC is the base, okay. So EC is the base and height is DM, right? So this is EC is the baseline and height of this triangle is this DM, okay. Now from this, right, from this equation, the left side ADE by DEB and here also ADE by DEC, right? So here DEB area and DEC area is the same, okay, that's what shown. So the left side fully terms is same, okay. Then the right side also equal, okay. So what do you have the right side here? Here EN cancel, off cancel, okay. What is there in the right side? It is AD by BD equal to, here also DM get cancelled, off get cancelled, and you have AE by EC again. So proved, right? I say, right, you need to remember 2 points to prove this concept, okay. One, okay, we need to find the triangle areas, okay. This ADB by DEB and ADE by DEC, okay. So we just create these ratios, okay, and then we make it equal, then it is, we will prove that, okay. The second logic you need to remember is, while taking the ratio of the ADE by DEB, you need to use this height and this base, okay. Similarly, when you are going for another ratio, you need to use this AE base and DM height, okay. That's only you need to remember. That's all. Why? Because it just get cancelled. If you use this side, it will not get cancelled, okay. With these 2 points, you can prove this theorem.